Today we are going to talk about finding rational zeros. So 2 learning goals for today. We need to be able to list the possible rational zeros of a polynomial function. And then once we can do that, we need to be able to use your calculator, synthetic division, and quadratic equation solution methods to find all real zeros of a polynomial function. Really important that you know what the different classifications of numbers are. Remember that integers are your numbers. It includes negatives, it includes zeros, but it doesn't include anything that is fractional. So these are examples of integers: -1, -2, 0, 1, 2, so on and so forth. Rational zeros includes the fractions. So it can be written as a fraction. Irrational numbers, remember, are the ones that cannot be written as a fraction. Real numbers, of course, are any number that we can put on the number line, so anything that does not have the imaginary I. So, in order to meet our first learning goal, we get that from the rational zero theorem. So if a polynomial has integer coefficients, so that means its coefficients cannot be fractions, they have to be integers, then every rational zero, so meaning every zero that can be written as a fraction, has the form p over q, where p is a factor of the constant term. Not p is the constant term, p is a factor of the constant term, and q is a factor of the leading coefficient. So we're going to illustrate that using example 1. So in this problem, in this polynomial, which is in standard form, make sure it's in standard form first. So I'll write that down, standard form first, so that you don't get confused on your constant and leading coefficient. My constant here is 5, my leading coefficient is 2. So when I go to list the possibilities, I'm listing the factors of 5 as my numerator. So the factors of 5 are positive and -1, positive and -5. Those are my possible numerators. My denominator possibilities are the factors of the leading coefficient, so positive and -1, positive and -2. So that means, so what I need to do here is to divide each of these numerators by each of the denominators. So my first set of possibilities are plus and minus 1 over 1. So that just gives me plus and minus 1. Then plus and minus 1 over plus and minus 2, so that leaves me the possibilities of positive or -1/2. So I did both possibilities with a numerator of 1, then I need to do numerator of 5. So plus and minus 5 over 1 would be plus and minus 5. Plus and minus 5 over 2 does not reduce, so that would be those possibilities. So there are our possible rational zeros. That doesn't mean these are rational zeros. That means if there's a rational zero, it has to be one of those. So this is how we're going to start all the problems. These are like our steps. Step 1 is to make a list of possibilities. Step 2 is to look in your calculator to narrow down the list. So we look at the graph. So we're going to graph this in our graphing calculator. So we're going to type in our function 2x cubed minus 5x squared and then our minus 2x, and then our plus 5. And when I graph that in a standard window, you can kind of look and see it looks something like this. And remember that zeros are x-intercepts. So you look at this x-intercept and you say, that looks like it might cross at -1. This x-intercept looks like it might be +1. And this x-intercept looks like it's between the 2 and the 3. So it might look like 2.5 possible. So I look at my list and I say, are any of those there? Well, plus and minus 1 are, so it looks like both of those might be zeros. 2.5 is 5 over 2. So that's what it looks like. Step 3 when we're finding zeros is going to be to confirm with synthetic division. So now I'm going to take one of these, it doesn't matter which one, and I'm going to confirm it with synthetic division. So I'll just start on the left. I'm going to start with -1. The polynomial is right here, so copy its coefficients. 2x cubed minus 5x squared minus 2x plus 5. Draw my vertical and horizontal lines. Bring down the first term. Box times bottom. Add. Box times bottom. Now add. Box times bottom and add. This confirms that -1 is indeed a 0 because again, if it's a 0, if it's an x-intercept, there shouldn't be a remainder and there isn't here. So that's step 3. We're going to confirm a 0 or more with synthetic division. Now, when we use that, the rational zero theorem, our calculator, synthetic division, what that does is it reduces our polynomial's degree to 2 or below. We need to get it down to where it's degree 2 or less. This started as degree 3, so that means this right here represents 2x squared minus 7x plus 5. So we have reduced it to degree 2 or below. If we can get it down to degree 2, that means what we have left, the polynomial that remains, is a quadratic. And we can solve the quadratic algebraically. That is step 4. So step 4, solve the quadratic algebraically. Now, it says right here how. How can I solve that quadratic algebraically? And that is your question. So, put a star by that. I'm not filling it in for you. Do not leave it blank. I want to see if you can come up with this. I'm going to check it tomorrow. So, how can you solve a quadratic equation algebraically? And if you don't know yet, by the time we finish example 2, you should be able to fill this out. Okay, so let's practice working through these steps to find all the real zeros of a function. So on here, first step 1, I'm going to make a list of the possibilities. So the factors of 9 would be plus and minus 1, plus and minus 3, plus and minus 9. So those are the factors of the constant. The leading coefficient is 1, so its only factors are positive and -1. So we love when that happens because it makes life a lot easier because over 1 just means these are the possibilities. So positive and -1, positive and -3, and positive and -9. So any zeros that I see when I graph this should be one of those for the rationals. So I type in my function, x cubed minus x squared minus 9x plus 9. Graph it in a standard window because that's my step 2. I'm going to graph it and I'm going to narrow down my possibility list. Now notice you can't see all the mins and maxes here, but that's okay. You don't need to be able to see all of those. All you really need are the x-intercepts. So it looks like this one has an x-intercept possibly here at -3. Then you can't see the top, but you can see it come back down and cross again at what looks like +1. And then it reaches a minimum and goes back up and looks like it crosses again, possibly here at +3. So for my narrowed down list, I'm going to say possibly -3, 1, 3. Step 3, confirm one of those with synthetic division. So, synthetic division doesn't matter which one you choose. I'm just going to start on the left, so I'm going to start with my -3. Copy the coefficients of your original polynomial, so 1x cubed, negative 1x squared, negative 9x, positive 9. Draw your verticals and horizontals and start your synthetic division. Box times bottom, add the column. Box times bottom, add the column. Box times bottom, add the column. Remember that this represents x squared minus 4x plus 3. Step 4 is to solve that quadratic algebraically, which means set it equal to 0 and solve for x. This one is factorable, so I'm going to go ahead and factor it. X minus 3 times x minus 1 equals 0, which means x minus 3 equals 0, x minus 1 equals 0. So x equals 3 is a 0 and x equals 1 is a 0. Do not, when you write your final list, forget to write the one that you confirmed with the synthetic division. Don't forget that one. Don't leave it out. So we also have x equals negative 3. So negative 3, positive 3, and 1. So we confirmed all of our suspicions here. All right, let's try that again. Step 1, factors of the constant. So factors of 6 there. Factors of 6 are plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. Factors of the leading coefficient, it's 1 again, so that makes it easy. So again, that means our possibilities are plus and minus 1, 2, 3, and 6. So step 2, I'm going to graph it to look at it and hopefully narrow down my list. So in your y equals, type in that function, x cubed minus 7x squared plus 10x plus 6. And when I graph that, I can just barely see all of it. Looks something like this. This first 0 crosses before negative 1. And since none of these are fractions, that means it's not in my list. I don't know what that 0 is. This one, pretty sure that that crosses at 3. Looks like 3. We'll find out. This one looks like it crosses somewhere between 4 and 5. But again, there aren't any fractions in my list. So that means I don't know what that is either. So whereas over here in example 2a, I had a choice what to confirm with synthetic division, here I have no choice. The only 0 that I can see that's in my list is 3. So I'm sure hoping that that's going to work out. So I go on to step 3 and I do my synthetic division. So my coefficients here are going to be 1, negative 7, 10, and 6. So draw my lines and get going. Box times bottom, add the column. Box times bottom, add the column. Box times bottom, add the column. Again, this represents x squared minus 4x minus 2. That is a quadratic, so if I set it equal to 0, I should be able to solve it. Now, this quadratic is not factorable. There's nothing that multiplies to negative 2 that's going to add to negative 4. So I need to choose another method. Here, I personally would choose to complete the square because there's no number in front of the x squared. And because this middle term is even, that means there's not going to be any fractions. So I'm going to move this to the other side. That's where this 2 came from. And I'm going to add my blanks. So to complete the square, I start with doing b divided by 2 squared. So negative 4 divided by 2 is negative 2, squared is 4. Multiply times the 1 that was in front, 1 times 4 is 4. So now, factor the left side as a PST. It's x minus 2 squared. On the right side, 2 plus 4 is 6. So now I can solve by taking square roots. So square root both sides, x minus 2 equals plus and minus radical 6, and then just add the 2. So x equals 2 plus or minus radical 6. These are the other two zeros that we didn't know where they were. The reason why we didn't know what they were is because they're square roots. They don't come out evenly. They're irrational, but they're still real. They're not imaginaries, so I still need them. Don't forget to list the one that you confirmed synthetically. So our zeros are x equals 3, and then x equals plus and minus radical 6. All right, last one. Step 1, list my possible rationals. Top would be factors of 540. Guys, I love these rational zeros because when you're looking at it and you can guess, you can say, oh, there's not a fraction in my list, so that one must be irrational. However, I like this because typically it saves you time and makes your guessing easier. Here, this step 1, there's too many factors to list. 540 is a huge number. So when you've got a huge number, more than 100, you're going to have to skip that step. As much as I love that step, here it just doesn't make sense to do it because it's not a time saver, it's a time waster. So we're going to skip on to step 2, and we're just going to go ahead and graph it and hope that we can guess well enough at what some of those zeros are. So we're going to go ahead and graph it. It's going to take you a while to type in because there's a lot of big numbers there. So 6x to the 4th plus 31x cubed, then minus 64x squared, minus 489x, and then minus 540. Now, when I graph that, it looks really crazy. It looks like a whole bunch of vertical lines. I promise you it's not a whole bunch of vertical lines. But that's what it looks like because in this window, we can't see it all. So if you want to adjust the window so you can see the mins and maxes, you can. But remember, all we really need are these x-intercepts. So you don't have to change the window. So on my calculator, it looks like this is probably at 4. This one, I'm not totally sure about. It looks pretty close to -2, but that one's kind of looking a little suspect on my graph. It doesn't look like it goes exactly through. So I'm not sure about that one. This one looks like it goes through -3. And then this one definitely goes between. I have no idea what that might be. So I'm going to start with one that I'm pretty sure about, which is the -3 to do step 3. So synthetic division, I'm going to start with my -3. Lots of numbers to list there. 6x to the 4th, 31x cubed, -64x squared, -489x, and then my -540. So bring down my 6. -3 times 6 is -18. 31 plus -18 is +13. -3 times 13 is -39. Add these. That gives you -103. -3 times -103 is +309. -489 plus 309 is -180. And -180 times -3 is +540. We should be very happy that that came out evenly. This represents 6x cubed plus 13x squared minus 103x minus 180. This is a problem because I did synthetic division and I don't have it down to a quadratic. That seems like a problem. It's really not a problem. I have to do a double synthetic because I need to confirm another one and reduce the degree by one more. Double synthetic, you use this row right here. You don't go back to the original. So you're going to use the answer row when you set it up. So I'm going to use 6, 13, -103, and -180. You don't need the remainder. as my row for my second synthetic. Now, because I wasn't totally sure about this -2, I'm going to use the 4 because the 4 looked pretty exact. Again, that's a matter of preference, but I just would not like to do synthetic division that isn't going to work. So bring down my 6. 4 times 6 is 24. Add, it gives me 37. Then 4 times your 37, box times bottom, is 148. -103 plus 148 is positive 45. 4 times 45 is 180. So this worked. Now, because I did double synthetic, I now have this down to 6x squared plus 37x plus 45. That is a quadratic that I can solve. Now, this quadratic, I don't know if it's factorable, but I would not like to find out. Those are big numbers, and this would be a split the middle. So when you've got big numbers like this, factoring, not the best method. Completing the square, definitely not the best method. You'd end up with all kinds of craziness. I would use the quadratic formula here. So I'm going to solve this doing opposite of b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So when I go to simplify, obviously the bottom here is 12. 37 squared, I don't know that off the top of my head, but if I use my calculator to help me out, it's 1,369. These, I know it's going to be a minus because there's only one negative, so do 4 times 6 times 45. That should give you 1,080. So 1,369, take away 1,080 gives me 289. So I've got -37 plus or minus the square root of 289 over 12. Square root of 289, this is why it's so advantageous to know your perfect squares. That comes out evenly. Don't waste your time doing a factor tree if it's a perfect square. 289 is a perfect square, and I'm running out of room, so I'm going to bring it over here a little bit. The square root of 289 is 17, so I've got -37 plus or minus 17 over 12. So -37 plus 17 is -20. So -20 over 12 is one of my solutions. -37 minus 17 is -54. So I've got -54 over 12 as my other solution. Now, we need to put these in simplest form. Hopefully you can see that those reduce. 20 and 12 both divisible by 4, so that's 5 and 3. So -5/3. I'm going to list these in a different color here so we can see them better. So x equals -5/3. X equals the 54 and the 12, both divisible by 6. This gives you 9, and this gives you 2. So -9 over 2. And then the 2 that I did with synthetic division, the 4 and the -3. So x equals 4, x equals -3. So again, the big idea with this last example was that we had to do another synthetic division because you have to get it down to a quadratic, and one synthetic division here only got us down to a cubic. So get it to a quadratic, we can always solve quadratics algebraically. All right, that is the end for this.